Okay, let's very quickly review all the steps. Here is a non-homogeneous differential equation. And so in order to solve it, what we do is first we write a general solution of the corresponding homogeneous equation. Then it has two general constants, C1 and C2. Then we replace these two general constants with functions of t, u1 of t and u2 of t, and then we apply a clever trick to simplify our calculations and to get an extra equation. Then we substitute it to the original differential equation, and together with this extra equation, it gives us a system of algebraic equations in unknowns u1 prime and u2 prime, and then we solve this system by Cramer's rule, and we got this formula for u1 prime and u2 prime. So the last step is just to integrate it. So if u1 prime is this, and u1 itself is going to be the antiderivative of t squared e to the 3t dt. Well, and of course you could do it 3 times by parts, but 2 times by parts, but I'll skip this. So this is going to be done by Wolfram alpha, and I'll just give you the final answer. The final answer is 9t squared minus 6t plus 2 over 27 e to the 3t. Now what I'm trying to do here, I'm trying to explain how the method works to you, and why the equations are those that you can find in the lecture notes. But I promise that if such a question appears in the midterm test, then actual calculations are going to be much simpler. So you don't have to integrate by parts 2 times or even 3 times. So here, u2 is going to be the integral of minus t cubed e to the 3t dt. So, and again by Wolfram alpha, the answer is minus 9t cubed minus 9t squared plus 6t minus 27 e to the 3t. So I promise that if you have to do it in class, then integration is going to be much simpler, and if you need to do it at home, then please feel free to use Wolfram alpha for integration. I mean, you still have to explain the steps. You need to apply the formula. You need to find u1 and u2 explicitly, but at least integration is going to be simple. Well, and then we just put together the final answer. I'm not sure if it is worth calling it another 6th step, but probably not. So let me just try the final answer. So the final answer is going to be u1 times t e to the minus 3t plus u2 e to the minus 3t. Right, so here is our u1 times e to the minus 3t. This just disappears. So it's 9t squared minus 6t plus 2 over 27 minus 9t times t. So it is actually t cubed, t squared, and 2t. Minus 9t cubed minus 9t squared plus 6t minus 2 over 27. Well, 9t cubed cancels out, so it is not as bad. Okay, so then we have minus 60 squared plus 90 squared, so this becomes 3t squared plus 2t minus 6t, so minus 4t. I hope I'm getting it right. Yeah, and minus 2 is just plus 2 over 27. Okay, finally, so this is a particular solution of the non-homogeneous differential equation. So this is, recall that this is a particular solution, which means that the final answer, the general solution of this non-homogeneous differential equation, is going to be this particular solution, 3t squared minus 4t plus 2 over 27, and plus the general solution of the corresponding homogeneous equation. Well, and recall that sorry, where is it? These two are linearly independent solutions of the homogeneous equation. So I just need to write C1 times t e to the minus 3t plus C2 e to the minus 3t. Okay, and this is actually the final answer.